Okay, so the problem we're working on is the U.S. Post Office will accept a box for shipment only if the sum of the height and girth, which is the distance around the bottom, is at most 108 inches. Find the dimensions of the largest acceptable box with the square top and bottom. So basically what you need to do is you first draw out the shape that you need to find the dimensions for, and in this case it's a box. And so since it's a box, it's a cube. No, it is not a cube, I'm sorry, I lied. It's a box. You don't exactly know the sides, like the length of the sides, so we're just gonna label those S. And another dimension that we need is the height of the box, so we're gonna label that as H. And so first things first, you need to find the perimeter of one of the sides. In this case, we're going to get the perimeter of the bottom side. So the equation for that is going to be P as a perimeter is equal to 4S. And what also we're going to need is the height. So we're just going to leave that as H. And so basically what we're doing is we're finding the maximum volume. And in order to find the maximum volume, you at first, I'm just going to put max volume. At first, what we do is we label the equation for finding the volume of the box, which is V is equal to S squared times height, which is a variation of V is equal to length times width times height. It's just a variation of that, but we're just going to use different variables. And so we have V equals S squared times height, and what we're given is the height and the girth needs to be at most 108 inches. So another equation that we need is 4S plus H is equal to 108 inches. And so this right here is how we find out our height. And so in order to find the height to plug it into this equation, what we need to do is we move this over. We move the 4S over. So we subtract the 4S from the equation, and we subtract it from both sides. So it'll be height is equal to 108 minus 4S. And so that's going to give us our height, which we will plug into here and create V is equal to S squared times 108 minus 4S. And so now we have that. Then we distribute and get V is equal to 108 S squared minus 4S cubed. So now we have this. We have our volume equation. What we need to do is find the derivative of V. And so we take the derivative of V, which we get derivative of V is equal to 216S minus 12S squared. And the way we got the derivative is we multiplied the exponent of the S part of this equation, multiplied that by the 108, by the coefficient, and got 216. And then we multiplied the coefficient for this part by the exponent and got 12, making sure to keep the negative. And we just subtracted 1 from each exponent. So we got 216 minus 12S. And what we're going to do is we're going to equal this to 0. So now both of our variables are together. Now we can solve for S. So what we do is we take out, this has like a common factor, and that factor is S. And so now we're left with 216 minus 12S is equal to 0. And so Okay, so this is honestly canceled out. You cancel, well, I mean, you can't cancel out the 0, but you can cancel out 1s, because this can be equal to 0 just by being 0. So then that leaves us with 216 minus 12s is equal to 0. So with this, now we solve for the remaining s. So we subtract 216 from both sides. That gives us negative 12. S is equal to negative 216. We divide both sides by negative 12, which gives us S is equal to 18. And so that gives us the dimensions of S here. That gives us the dimension of one part. So basically, we've already gotten most of this equation down. So V is equal to 18 squared times H. So now that we found our S, we can plug it into the equation and now we can solve for our height by doing this. We actually go back to the height equation, which is H is equal to, actually, forget about that. That was absolutely useless. We go back to our height equation, which is H is equal to 108 minus 4s. And we have our s now, which is 18. So we minus 4 times 18, which gives us 36 as our height. And so now we found the dimensions of what our box needs in order for it to be the largest maximum volume for shipping it. And that is, our sides need to be 18 inches long, and the height of it needs to be 36 inches long.